Hello friends, in today's class we are going to see the construction and working principle of capacitive transducer. First we know that what is a transducer. A transducer is a device which converts a non-electrical quantity into an electrical quantity. Now another way we can define transducers as a device which converts one form of energy into another form of energy. So here what is a capacitive transducer? So capacitive transducers converts non-electrical quantity into electrical quantity by means of change in capacitance. So here the capacitive transducer is a transducer which convert a non-electrical quantity into electrical quantity by means of change in capacitance. So what is that non-electrical quantities? So this non-electrical quantities are nothing but the physical quantities like displacement, force, pressure, flow, torque, level, etc. So this non-electrical quantities are nothing but the physical quantities like displacement, force, pressure, flow, torque, level, etc. So this capacitive transducer convert these non-electrical quantities into an electrical quantity. It may be either an electrical voltage or current in the output. So this non-electrical quantities are converted into electrical quantities like voltage or current in the output. So the principle of operation of capacitive transducer is based on the equation of capacitance of a parallel plate capacitor. So the principle of operation of this capacitive transducers is based on the equation of capacitance of a parallel plate capacitor. We will see what is a parallel plate capacitor. So the parallel plate capacitor has a top plate and a bottom plate. So in between the top plate and bottom plate there will be a dielectric medium. So this one is the top plate and this one is the bottom plate. In between the top plate and the bottom plate is the dielectric material. So this top plate and bottom plate is at a distance of d between them. It is placed at a distance d between them, and the length of the plate is taken as L and the width of the plate is represented as W. So the top and the bottom plate, in between the top and bottom plate there is a dielectric material. The distance between the top and the bottom plate is represented as d, and the length of the plate is taken as L and the width of the plate is taken as W. So from this we will write the equation for capacitance of a parallel plate capacitor, where C is equal to epsilon A divided by D. So epsilon is equal to epsilon naught A divided by D. So here epsilon is called the permittivity of the medium. It is the permittivity of the dielectric medium, where epsilon is equal to epsilon r into epsilon naught. Here epsilon r is the relative permittivity, epsilon r is the relative permittivity, and epsilon naught is the permittivity of free space. So the permittivity of the free space is given by 8.85 into 10 power minus 12 farad per meter is the permittivity of free space, and here A is the overlapping area of the plates and D is the distance between the plates. So here we know that the equation for the capacitor is given by C is equal to epsilon into A by D, where epsilon is the permittivity of the medium, and we can write epsilon as epsilon r into epsilon r, which is the relative permittivity and permittivity of free space, and A is the overlapping area of the plates and D is the distance between the plates. So the value of a capacitance of a parallel plate capacitor depends on these three factors. One is the permittivity, and second one is the overlapping area, and third one is the distance between the plates. So we can change the capacitance value by changing the value of epsilon, A and D. So where epsilon value depends on the dielectric medium, and A the area between the plates, and D is the distance between the plates. So the capacitive transducers works on the principle of change in the capacitance. The capacitive transducer works on the principle of change in capacitance. So the change in capacitance may be caused by three factors, which is caused by, we can change the value of the capacitance by changing overlapping area A of the plates. Second one, we can change the distance D between the plates, and third, we can change the capacitance by change in dielectric constant between the two plates. So by varying the area and the distance and the dielectric constants, we can change the value of the capacitor in case of capacitive transducers. So this change in area, distance and dielectric constant is done by the physical variables, because these physical variables like displacement, force, pressure, level, etc. will change the value of the capacitance. That is, will change the value of area, distance and dielectric medium in the capacitor, so that the value of capacitor changes, which in turn is converted into electrical output. So in capacitive transducer, capacitance is measured by with the help of a bridge circuits. So with the help of a bridge circuit, we can measure the value of a capacitor. So in this case, the output impedance of the capacitor is given by Xc is equal to 1 by 2 pi Fc, where F is the frequency and C is the capacitance value. So the output impedance Xc is given by 1 by 2 pi Fc, where F is the frequency and C is the capacitance. So we can use the bridge circuit, which can measure the value of capacitance or the output impedance of the capacitive transducer. So in capacitive transducers, we can use any of the physical variables to change the capacitance in capacitive transducer to convert non-electrical quantity into electrical quantity. So as we see, the physical variables like displacement, pressure, force, level, flow, etc. can be used to change the capacitance value in the capacitive transducer to convert that non-electrical quantity, that is the physical variables, into electrical quantity. Now let us see the advantages of capacitive transducer. First advantage is it requires extremely small force to operate them, and hence useful for use in the small systems. So generally the capacitive transducers or the passive transducers, that is it requires external source for their conversion, that is for converting non-electrical quantity into electrical quantity it needs an external source. So this is also called as externally powered transducers, because the capacitive transducers are passive transducers which require external source for their conversion of electrical quantity into non-electrical quantity into electrical quantity. So these are called as externally powered transducers. The second advantage is they are extremely sensitive. So the capacitive transducers are highly sensitive or extremely sensitive, and it can be used for small systems. So it can be used for even very small systems because it is highly sensitive. And the third advantage is it has good frequency response. So the capacitive transducer has good frequency response because the output is very high as the frequency is increased. So it can be used for dynamic studies also. So with the increase in frequency the output also increases. So it can be used for dynamic studies. So the capacitive transducer has good frequency response. And the fourth advantage is it has very high input impedance. So it has less loading effect. So input impedance of the capacitive transducer is very high, so it has very less loading effect. There is a condition for loading effect, which is nothing but for removing the loading effect there must be high input impedance and low output impedance. So capacitive transducer has very high input impedance, so we can say that it has very less loading effect. And the fifth advantage is a resolution of order of 2.5 into 10 power minus 3 mm can be obtained in capacitive transducer. A resolution of order of 2.5 into 10 power minus 3 mm can be obtained in capacitive transducer. That is, the minute changes in the displacement can also be measured using this capacitive transducers. And the next advantage is, since force requirement is small, so it requires only small power to operate them. As we have seen that the capacitive transducer require extremely small force to operate them, so the amount of power required to operate them is also very small. So it is an advantage of capacitive transducer. So in the advantages of capacitive transducer, it requires only small force for operating them, so we can use for even a small systems, and they are highly sensitive, has good frequency response and very high input impedance, so the loading effect is also less, and it has a very high resolution, so even minute change in displacement can be easily measured by using a capacitive transducer, and the force requirement is small, so the power required to operate them is also small. Next we will see the disadvantages of capacitive transducer. First one is the metallic parts of the transducers must be insulated from each other in order to reduce the effects of stray capacitance. So in order to protect the metallic parts of the transducer from the environmental conditions like the effect of stray capacitance, it must be insulated from each other so that it can be easily protected from the external stray capacitances. So this external stray capacitance will not affect the capacitance value when it is insulated. The second one is the capacitive transducer shows nonlinear behavior due to the presence of edge effects. due to the presence of edge effects, the capacitive transducer shows non-linear behavior. So this edge effects can be eliminated by using guard rings. So the guard rings will eliminate the effect of edge effects, which is responsible for the non-linear behavior of the capacitive transducer. And the third one is the output impedance is high on account of the small capacitance, which leads to loading effects. So the output impedance is very high on account of the capacitance, which leads to loading effect. We know the condition for loading effect, that is the input impedance is high in case of capacitive transducer, which is the advantage of capacitive transducer. So the effect of loading effect is less. But if we see the output impedance of a capacitive transducer, it is low, but not, it must be low for less loading effect, but it is not so in the case of capacitive transducer, because the output impedance is high in case of capacitive transducers. So it is a disadvantage which causes the loading effect. Fourth one, the cables connecting the transducers of the measuring point is also a source of error in case of capacitive transducers. So the cable which is used for connecting the transducers to the measuring point also have some impedances value which is added to the capacitance. So while measuring the value of capacitance, the capacitance of the cables will be included, that is the impedance of the cables will be included while measuring the values of the capacitance, which causes error in case of capacitive transducer. So this is also a disadvantage of capacitive transducer. So we have 4 disadvantages. One is the metallic parts of the transducers must be insulated in order to reduce the effect of stray capacitance. So it must be shielded. And next one is due to the edge effect, it shows a non-linear behavior which can be eliminated by using guard rings. And the third one is the output impedance is high in case of capacitive transducers, which leads to loading effect. And for the fourth one is the cable which are used to connect the transducers to the measuring point causes error, because the impedance of the cables which will get added to the capacitance while measuring the value of the capacitance. Next we will see the applications and uses of capacitive transducer. So in capacitive transducers, we can measure the physical quantities like force, displacement, pressure, etc. by changing the value of the capacitances, which is measured in terms of electrical quantities. So the capacitive transducer converts these physical parameters into an electrical quantities, that may be a voltage or current. First one is they can be used for measurement of both linear and angular displacement. It can be used for both linear and angular displacement. So here the capacitive transducers measure extremely small displacement down to the order of molecular displacement, that is 0.1 into 10 power minus 6 mm. So we can measure the displacement down to the order of molecular displacement, that is even 0.1 into 10 power 6 mm of displacement can be easily measured by using capacitive transducers. The next one is they can be used for large displacement measurement up to 30 meter. So, up to a large displacement of 30 meter can be easily measured by using capacitive transducers. So, the capacitive transducers are used for the measurement of both linear and angular displacement. And the second application is the capacitive transducer can be used to measure the force and pressure. So, we can measure the force and pressure by using capacitive transducer. First, the force and pressure is converted into displacement. Then this displacement is converted, that is, this displacement will change the value of the capacitance, which in turn converted into an electrical quantity. So, the capacitive transducers can be used to measure the force and pressure, which is first converted into displacement, and then that causes the change in capacitance, which is measured as electrical output. And the third application is they can also be used as direct pressure transducer. In all those cases where the dielectric constant of a medium changes due to change in pressure. So, this capacitive transducers can also be used as a direct pressure transducers in cases where the dielectric constant of a medium changes. So, this dielectric medium changes, it changes the permittivity of the capacitor, so that the capacitance also changes due to change in pressure. The fourth one, they are used for measurement of humidity in gases. They can be used for the measurement of humidity in gases, because as the humidity changes, the change in humidity will change the dielectric constant, which changes the value of capacitance. So, the change in capacitance is converted into an electrical quantity in capacitive transducer. Next one, they are used in conjunction with mechanical modifiers for measurement of volume, density, liquid level, weight, etc. So, with conjunction with mechanical modifiers, this capacitive transducer can be used for the measurement of volume, density, liquid level and weight, etc. So, these quantities are nothing but the mechanical quantities. So, they can be directly measured, which changes the value of the capacitance. Example, this liquid level changes the dielectric constant of the capacitance, which in turn changes the value of the capacitor. So, we can measure this mechanical quantities by using a capacitive transducer. So, in the application or the uses of capacitive transducer, it can be used for both linear and angular displacement. So, displacement of the order of 0.1 into 10 power minus 6 mm up to 30 mm can be easily measured with the help of this capacitive transducers. And second one, it can be also used for the measurement of force and pressure, because first the force and pressure will be converted into displacement, then the displacement will change the value of the capacitance, which in turn is converted into electrical quantity. And third one, it can also be used as direct pressure transducers, because where the dielectric constant changes due to change in pressure, because the change in pressure transducer will change the value of the dielectric constant of the medium of a capacitor, which in turn changes the capacitance value. And the next one is, it can also be used for the measurement of humidity in gases, because the change in humidity will change the dielectric constant, which in turn changes the permittivity of the capacitor, which in turn changes the capacitance value. And also in conjunction with mechanical modifiers, it can be used for the measurement of volume, density, liquid level, weight, etc.